Okay, so my name is Ian Yule. A bit of my background, I was Professor of Precision Agriculture at Massey University and started using this type of technology around a decade ago. 3 years ago, I moved to PlantTech, where we wanted to establish a regional research institute, and remote sensing has become an important component of that. We've now got a team of about 20 mostly PhDs in the area. Most of their qualifications are in the area of data science rather than agriculture and horticulture, but we're applying these sorts of technologies and data analytics, etc., to the agriculture and horticultural areas. So the team that are working in remote sensing are listed here. Reddy, who you'll hear from, Ishvan, Mohammed, Alvaro, you'll also hear from. So we have a remote sensing team, we have a larger proximal sensing team, and then a data analytics team as well. So we're working very much in industry related problems. So why would I show a slide of spectral imaging 101 to a group like this? Well, I think it's important when we're to think about the advantages of each of those types of scenarios. So RGB imagery, we use it all the time. And the big advantage to me is that we've got immediate feedback. We use our eyes, we've got immediate feedback. And for people that are working in industries like agriculture and horticulture, that's really, really important. And again, with the RGB imagery, we've got really high resolution, and there are ways that we can use that high resolution to find things much more readily than we can, say, with a larger but hyper or multispectral instrument. We went through a period in the 2000s of using multispectral instruments, and they have some advantages and some disadvantages. The main advantages was detecting differences in the NIR compared to the RGB and looking at various ratios and so on, and the fact that we could use artificial light, so we could use these instruments 24/7. So that was another advantage. So most of us are interested in hyperspectral imaging. And that really is, it's got a tremendous potential. I saw the potential 10 years ago. Have been working on that with the likes of Reddy and so on to exploit what hyperspectral imaging can do for agriculture and horticulture. So just to give you an example of what type of thing we do, is we have we use an Phoenix from Speckham in Finland. It's a camera that has 364 channels. It's got from I think around the 400 to the 2,500 nanometer, and we use it really in terms of airborne surveys. And the big advantage is that we can get a tremendous depth of information over larger areas, and that the area there that you're looking at is around Kari, which is in the Bay of Plenty. Those areas in purple are avocado orchards, and I think that survey area is around 12,000 hectares. So the GSD is 1 square meter or 1 meter, and as I say, tremendous depth of information that we can get from this system. And so there's just an example of what the camera looks like in the plane. We've got a flight plan. Here's the plane that we use. And we also use a digital, just a DLSR camera to take the RGB imagery as well. And we'll fly that's actually the flight plan around Tapuki, which we flew half of yesterday, and hopefully we'll fly the other half today. So that's the sort of equipment that we're using. Okay, so there's a secondary pilot. There's a pilot, and then there's someone sitting in the plane operating that, and that's run by a kind of a joint venture between Massey Ventures and Ravensdown Fertilizer Company. It's called Hyperceptions, and they run that service to collect that information. So I guess Reddy and I have been doing this type of work for a long time, and maybe I've say a decade of developing the technology. Maybe it's more like a decade of trying to understand the technology and utilize the technology. And I think the first sorts of things that we had to do were understand some of the limitations. We've latterly been also using some laboratory equipment for other types of applications. But the main vehicle for our learnings, if you like, has been a large project that was run by Ravensdown, and it was in New Zealand's hill country. And it's a pretty challenging area to try and work in. And a lot of what we had to do was around applying, well, really calibration, validation. And what we were trying to do is estimate soil fertility in this type of terrain, a pretty challenging task. So at first we developed some calibration algorithms, and then we went to validate, and then what we've tried to do is independently validate in other areas and so on. So a typical survey might be, here's a farm example of, I think this is a 2,500 hectare farm. You can see it looks relatively flat, but believe me, when you're on the ground, it's not. So we'd capture the data with the camera, and this is the type of thing that we would produce. This is an estimate of soil Olsen P, and the level of resolution that you can achieve here is far greater than taking soil samples. You know, sending people out over these large farms becomes very expensive. You've got to put you know, larger numbers of samples in, and traditionally what's happened is they've actually used very few samples. The fertilizer is flown on to the farm in this instance, and this Ravensdown have developed a computer control system around the aircraft that can switch to different rates of fertilizer so that we get an optimized rate of fertilizer on any part of the farm. So that was the aim of that project, and that's reaching its end, and it will be, I think, commercialized later this year as a product coming out from Ravensdown. So what we've done at PlantTech then is we've actually utilized some of the similar approaches, looking at kiwifruit orchards and so on. And so again, a lot of ground truthing. I've mentioned that we fly various missions over different parts of the country. So here's 3 examples that we're currently working on. So at Te Puke, there's the area that you see there is mainly kiwifruit orchards. So the areas in that scene are highlighted are kiwifruit orchards. The one in the middle is apple orchards around Hastings. So there's around 6,000 hectares that we're just in the middle of surveying there. And as I've mentioned before, about 12,000 hectares around Kerikeri. So other things that we can do is, as well as quantify nutrients in our canopies, we can also look at biodiversity, identify different species of trees, different habitats, etc. As I say, it provides a really rich source of information. So this is some work that Mohammed did just recently, looking at in the Te Puke area, looking at the foliar nitrogen, and just, if you like, the ground truthing, comparing the ground truthing to what we were predicting. I think most of you would see that that's probably pretty typical levels that you would get for those types of relationships. The advantage is that we can then look at others. So again, I think you would find that that's probably pretty typical of what you would see in terms of trying to predict phosphorus, potassium, calcium, and iron. But one of the things that we're doing here at PlantTech is using a different approach. So traditionally, there's been an approach of scientific experimentation through field experiments. And what we want to do is look at industry-wide data. So we're working with the industries for 2 reasons. One is, if we find no economic advantage in using these technologies, then why would we persist in using them? And so really that's one of the main things that we're working on at the moment. Is there a definite economic advantage from knowing that your different attributes of your canopy? And if there is, then can we use that to benchmark what good practice looks like, so that people have something to aim for, so that we can improve management and so on. So the approach is quite different. So we're working with taking larger areas of information, and we want to use economic data from the industry, as well as the hyperspectral information, as well as orchard information as well. We then use that with the post-harvest, harvest and post-harvest data on the yield, the size, distribution of apples or kiwifruit, etc., the general health of the crop. And We can look at different stresses in our crops, and so Ishvan, for example, has been using SAR, synthetic aperture radar, and we have a project going on there. And Alvaro will talk a little bit about fluorescence later, and some of the work that we're doing there. So we're trying to integrate other sensors, and as you can imagine, all of this is getting fairly complicated. And the green outline there is really, if you like, around the traditional sources of information that we might use. What we're trying to do is use information on a much bigger scale, physical scale, if you like, introduce more AI into that in terms of getting better information for better decision making. So another, I'll just briefly mention the use of LiDAR. So we are combining LiDAR with hyperspectral information as well, and I'm sure there are lots of people around the world doing this. What we're trying to do is look at, say, individual tree.
4 minutes to go.
Yep. Okay. So individual tree metrics on avocado. This can be done in different crops, but you can imagine that from the previous presentation, there's lots of challenges about trying to do this from the air in different conditions, light angles, etc., etc. So it is quite a challenge, but we think we're making some pretty significant progress. Another area worth considering is around carbon sequestration. If you can use LiDAR in conjunction with hyperspectral, not only do we get the physical size of what's happening, but we can also look at the diversity in terms of species and so on. So again, Ishvan has been looking at some of these types of things, and can we then predict some carbon sequestration from the landscape in a lot more detail than a lot of the models that are used either at regional, national scale that have carried a huge number of assumptions. So I'll just try to illustrate some of the types of applications that we're working on. As I say, it's been a decade of learning. Really, we started off with some basics, just looking at trying to understand the data using some very basic statistical methods, understanding validation, survey limitations, etc. The emphasis in the last 3-4 years has been really to scale up, speed up, improve model robustness and transferability. So can you use the same model in Northland that you can use in Dunedin or so on? Lots of new possibilities in data analysis methods. So certainly beginning to apply machine learning, deep learning, and that's something that Mohammed's looking at, sensor data integration. And then I've just put in here the need, I mentioned it previously, the need for a transition from scientific knowledge to business intelligence. If we want to see these types of technologies used, then there's got to be an economic rationale for using them. And that's, if you like, what we're trying to do with with all of the apple, Kiwifruit and avocado industries, is to show investigate what advantages come from these. And then the final thing is, are they fit for purpose? I mean, I think the key thing for me is that a lot of these sensors can offer a huge amount of information, but we've got to understand some of their limitations. We've got to understand that we can do things incorrectly, that we can make errors. And I think the whole thing around uncertainty is also very important, that was talked about previously. So just from a very general point of view, that was the sorts of things that I wanted to just open up the discussion, show some examples of how it can be used. I know other people will do some different examples, but hopefully you found that interesting. Okay, thank you.